So we just need for this question, so it's question number 5 from revision quiz number 1, and we're given a random variable t observing a y-ball distribution with a shape parameter beta equals 0.7 and eta equals 0.9, which is the characteristic life, and we're trying to get some probabilities. So we want the probability that t is greater than 1, probability that t is greater than 1, and the probability that t is less than 0.9. So I'm going to split these in two because they're going to be slightly different questions. So we need different equations, that's all. So the probability that t is going to be greater than that, we're going to use r of t, reliability equation. And for a y-ball distribution, I had this a second ago, r of t is equal to e to the minus t on eta all to the beta. So in this case we've got e to the minus, so we want greater than 1.8, so 1.8 over eta, which is 0.9, all to the beta, which is 0.7. And that's going to give us e to the minus 1 times 1.8 divided by 0.1, 0.9, 0.9 raised to the 0.7. And that's going to give us a value of 0.197. And we want 3 different places? Yes, we do. Okay, part number II, this one, we want the probability that t is less than 0.9, so that's going to be a cumulative failure rate, so big F of t, and that one's going to be equation number 51 as well. They're both in the exact same spot, handily. Well, I mean, it's pretty obvious, that's just one minus the other one, so e to the minus, well, let's just plug it straight in, 0.9, well, it's 0.9 on 0.9, so we just might as well say 1. Well, this is going to be pretty easy because 1 to the anything is just going to be 1, so we've actually just got, we didn't need this at all, it's just going to be e to the minus 1, and that means it's 1 minus 1 on e, which is equal to 1 minus e to the minus 1 equals 0.632. And you know what, that should have been pretty obvious because 0.632 is just tweaked my memory because it's a magic number, and we were actually given the probability that t is less than 0.9, and that was our characteristic life. So when you get those two numbers the same, it's always 0.632, so that the failures happen. If you remember the graph of a y-ball distribution, then the failures by the, when this is equal to eta, then that area in there is equal to 0.632. So I hope that makes sense. We'll see you in the next question.